In my previous two videos, I talked about multicast filtering in general and IGMP query, the IGMP forwarding and the data forwarding, the router part and the member part. In this video, let's continue the discussion about the fast leave option and forward and no multicast traffic option. First, fast leave. This is my lab environment. I have 3 UniFi switches. The one closest to the gateway is 24-port Pro switch. Then the second switch is a enterprise PoE. The third one is a small PoE switch. I have a multicast video source connected to the first switch. By the way, the first switch is the IGMP query in my environment. Then I have 2 multicast video receivers connected to the other 2 switches. On all the 3 hosts, I will run Wireshark. At the same time, I will run 2 extra Wireshark instances. They will be monitoring these 2 ports, the port A in this switch and port 26 in this switch. These 2 ports are special because you can see they are marked as green color because in this environment, they are the multicast router ports. In the 5 Wireshark sessions, I'm going to apply the same display filter. You can see, for example, this one, IGMP, of course, and then I filter on 3 multicast groups. Why these 3? So the 239.255.0.1 is the multicast group I'm going to use for the demo video multicast. And then the other 2, they are special multicast group used in IGMP messages. In this slide, I mentioned the special multicast destination groups. 224.0.0.1 is used for the general query among all the switches or multicast routers. And then this leave message is very important for this video because that's closely related to the fast leave function, and this type of message will be sent to the 224.0.0.2. So that's why in Wireshark I filtered the packets in this way so that we only see the packets which we are interested. As you can see now in UniFi Network Controller, the fast leave function is disabled. So let's see by default, when the fast leave is not enabled, how the leave message is sent out and what's the effect of the leave message. So in the file Wireshark, let me start capturing. Okay, they all started. Now you can see it's very quiet because I don't have any multicast streaming activities yet. But you can already see the general member query, which is sent out from the .1.201 IP address. It is from the first switch, the Pro 24. As I mentioned, this switch is the multicast query. That's why it is this switch that sent out the general membership query. Now from the multicast source, which is this machine, let me start the video source. Started. You can see the time is changing, which means the video multicast is going on already, but we don't see any new activities from the IGMP messaging perspective. The reason is we don't have multicast receiver activated yet, right? So now from this session, which is corresponding to this particular multicast receiver, let me start the streaming. Okay, so now you can see the video started, right? Minimize it. So let's examine what happened. From this particular machine, you can see a new message type. It is membership report. It is sent out from this particular computer. And then you can see this message report was not received from this multicast source. It was not received from this multicast receiver. Instead, it's received and only received in this Wireshark. So this Wireshark is corresponding to this one in the diagram, which is monitoring port 26. As I explained in my previous video, because this part is the router port, the membership report message will be forwarded through this part to the query. Okay, so far so good, right? And then from the third window, which is for the other multicast receiver, let me start the streaming as well. Okay, started. So you can see another set of membership report is sent out, but this time it's from this receiver, right? Different IP address. And you can see it is forwarded through the other router port, which is the port 8 here. Okay, now let's close one multicast receiver, which will end with a leave message. For example, if I close this particular multicast receiver, let me close the window. See, let's examine the message, right? This particular machine send out the leave group message and send to which IP address? This 00.2 IP address, right? That's for the leave message. See what happened after that? We got two specific membership query. You can see we received two special membership query. The second one sent out from .1.201, which is the first switch. This packet makes sense because, as I mentioned, the first switch, it is the IGMP querier. It is responsible to collect all the membership information after it received the leave message from this particular multicast receiver. It will query the membership information again. Query what? Query this part just to make sure whether from this part there is still any multicast receiver. If there's no, starting from that point, it will not forward the UDP packets for the video to this part. So that's the purpose of the leave group message, because if this receiver already left the group, there's no point to forward the UDP packets anymore to this part, right? So that's why this particular membership query specific for this group, this one makes sense. But the other one is interesting. See, it's the similar specific membership query, but it is from the 000 IP address. If we double click on this packet, we can find out the MAC address for the source. See, this packet was sent out from a UniFi switch. We can confirm which switch it is. The MAC address ends with 7F div230. So let's find it out from UniFi network controller. Check whether it's the Pro 24. No, it's not. So whether it is the small PoE switch. No, it's not. So then whether it's the enterprise PoE? Yes, it is. See this MAC address? This is interesting, right? Based on what we observe, this particular enterprise send out a specific membership query. But why the source IP address shows as R0? Remember I show you the network configuration. I already made sure I have the IP address specified for all the three switches. For example, for the enterprise switch, I have this IP address specified. So here why the IP address shows as R0, I am not 100% sure, but I tend to think this is a bug from Ubiquiti. I should see this .1.202 IP address instead of R0. But this is not really related to this video. I just want to show you the strange R0 IP address I can see here. Now you see the two specific membership queries from the two switches, right? But how these two specific membership queries messages, how they are related to the data packets about the video. To make sure we understand the timing for the two type of messages, let me remove the display filter. Okay, after these two membership queries, there are still UDP packets sent out from the multicast source, which means after this multicast receiver already left the group, the data packets were still forwarded to the port, right? But does it forward it forever? No, it only lasted for a short time, then it's gone. See, when we stop the capturing, we don't have those UDP packets anymore. But at least for several seconds, this part still continued to receive these UDP packets. It did stop at some point. So why? Because we didn't enable fast leave. Let me go back to the old filter. Let's talk about the sequence of this message. So at this point, this leave group message, we just closed the multicast receiver. It just left. Starting from this time, the port will continue be flooded with the data packets about the video because the switches are still not sure whether it need to continue to forward the data packets or not. How the switch can be sure? The switch send out the specific membership query. After the specific membership query, it didn't receive any membership report from this port. That's why after several seconds, the switch decided to stop forwarding the data packets to this port 1. So that's why we need to wait for several seconds as we observed from Wireshark, and then the data packets stopped. That's the effect if you don't enable the fast leave, because it's not fast. You need to wait for some time. The switch need to be absolutely sure. Having observed how regular leave works, now let's enable fast leave. Okay, enable for default network, apply changes. Okay, it's done. Now let me start the packet capturing for the 5 Wireshark sessions. Okay, we haven't started streaming yet, so you only see the general membership queries, nothing's special. Now let me start the streaming from this multicast source. Start. Okay, it's started. Then from the first multicast receiver, this one, let me start the streaming. Okay, started. Then you can see the expected membership report group message from this particular multicast receiver, right? Then start the second multicast receiver. Okay, also started. So far so good. Just like the previous testing, let me close this particular multicast receiver's streaming. Close it. See, did you notice the difference compared to last time? This time you only see the leave group message sent from this computer, but you don't see the group specific query sent from the switches, right? That's the difference you can observe just from the IGMP perspective. If we go to the UDP, the data packet, you will see the real difference. Let me remove the filtering from this machine and remove the filtering from this machine. From this particular multicast receiver, you can see it has been receiving the multicast data packet continuously as expected, right? And for this left side, the first multicast receiver, it doesn't receive those data packets also as expected because it already stopped the streaming, right? But if we go to the point where we just close the streaming window. Let me find that message. This is the leave group message we saw. See what's the difference? Before this message, it has tons of data packets. Right after this message, nothing was received when it comes to the UDP packets. Why is that? Because we enabled the fast leave. The difference between enabling fast leave or not is whether the switch will query about whether this part still has the multicast receiver or not for this particular group. That's difference number 1. We don't see that query sent from the switch, right? The second difference is right after the switch receives the leave group message, it will immediately cut or stop the data packet. It won't forward the data packet to this part anymore. That's why right after this one, you see there's no data packet already. So the benefit apparently is it can save some network bandwidth because the system doesn't need to wait. It can stop the data packet forwarding immediately, right? Someone may ask, then it seems it's a perfect idea, right? Because after this point, we don't need the data packet anymore. Then what's the point for the switch to take extra effort to query whether there's still multicast receiver, then wait for several seconds, then stop forwarding? There's no benefit, right? So then why not simply enable the fast leave everywhere? So now let's discuss the side effect or downside of enabling fast leave. In the two tests we just did, all the switches are UniFi switches, and all the multicast receivers, they directly connect to a part of a UniFi switch. So that's why it seems the fast leave option should be enabled by default. But let's consider another environment. So here I use a third-party unmanaged switch or dumb switch. For this switch, I connect two multicast receivers, and this switch is linked with a UniFi switch. So then let's see for this particular environment whether the fast leave will cause any trouble. In the new test environment, let me disable fast leave first. Then in the 3 remote sessions, let me start the Wireshark capturing. Okay, started. Now the environment is very quiet. We see the regular membership query from the UniFi switch, the first switch, which is a query. Then from this multicast source, this machine, let me start the streaming. Okay, it started. Then let me start receiving. Okay, you see the membership report sent out from this particular receiver machine, right? And interestingly, in the right side, you can see it also received the same packet sent out from this receiver. Even though in all of our previous testings, when we use UniFi switches, the other receivers, they are not supposed to receive the membership report from other receivers, right? But why this time this client also received the same report from other receivers? It's because we are using the unmanaged switch. It doesn't know IGMP snooping. It simply forward whatever packets it received to all the ports. So that's why we see this situation, right? Okay, let's proceed. Then from this multicast receiver, let me also start streaming. Okay, the streaming started, but you can see there's a very noticeable delay in the second video because this switch is so weak. Apparently it's super busy now, just flooding the tons of UDP packets to all the ports, right? So now in the first multicast receiver, let me stop receiving. See, it send out the leave group message, and then immediately we received two membership queries, specific one, and they are from the two different UniFi switches. In the right side receiver, you can see the video is still continue playing, and in the captured packet, you can see the membership report sent out from this receiver. That's the reason why the video is still playing, because after the two switches ask for the membership information, they received the membership report from the second receiver, so the switches decide not to stop the data packet forwarding. That's why the second video is still playing. Remember, now we don't have the fast leave enabled yet, which means even though this switch is slow, we see some delay, at least everything still works fine for the two multicast receivers, right? After closing this first receiver, the second receiver is not impacted. Okay, now let's enable fast leaving. Go to UniFi network controller, enable fast leave. Default network, save, apply changes. Okay, then start the Wireshark capturing. Okay, from the multicast source, let me start streaming. Started. Then from the first multicast receiver, let me start receiving. Okay, then in the second receiver, start receiving. Okay, so far so good. Then in the first receiver, let me stop the receiving. Okay, see the leave group was sent, and then there's no specific group membership query sent out from the UniFi switches, right? So then see what happened in the right side. The video just stuck there. See the right side multicast receiver, it didn't give up. It sent out the membership report group, and then the streaming resumed. So then let me stop capturing. Let's try to understand what happened. Why the sudden pause of the video, and then later it can resume by itself. So to understand what happened after this leave group message, let me add a filtering so that we can see UDP packets as well. Okay, before this leave group, there were tons of UDP packets from the multicast source for the video, right? Right after this one, the leave group message, nothing's found from the multicast source. So the UniFi switches, these two switches, immediately stopped forwarding the data packets to this port 1 so that this third-party switch didn't receive any new UDP packets after this leave group, right? But after a while, this UniFi switch sent out the membership query packet, and then this particular multicast receiver replied and claiming it is also part of this multicast group. It is a member. Then see after this membership report group message, what happened? Let me add back UDP. See, right after this membership report group message, the UniFi switches decided to forward the data packet to this port so that this third-party switch continued to receive the UDP packets. That's why there was a short delay in the video. So let's see how many seconds the video was stuck. So from this one to this one, see, there were 32 seconds. After more than half a minute, the video got resumed. Okay, let me explain what's the reason. The fast leave option only works if for a part there's only one host attached. So for example, for this part 1, only one host. For this part 1, there's only one host, right? But if you check this scenario, for this UniFi switch, for this part, there are two hosts, right? So if we enable fast leave, the system will brutally cut the data packet for this part, then all the attached hosts will be impacted. Okay, I hope it's clear about what's the downside or potential issues if you enable fast leave. The next topic, forward unknown multicast traffic. So if you move your mouse cursor here, you will see this so-called help. As expected, it doesn't help at all. So let's do some testing to see what it is about at all. After we enable IGMP snooping, the switches will only forward the multicast traffic to the ports if from the ports, there are multicast receivers registered. They requested to receive the packets from a specific multicast destination group. So those type of traffic is called known multicast traffic. Here the unknown means if there's some multicast traffic for some multicast destination group which the switch is not aware of what they are for. If that's the case, those traffic is considered as unknown. By default, the switch will drop them. So no devices or hosts will receive those traffic. Normally, that should be fine, but for some special devices, for example, some musical instruments, if you drop the packets, those equipments won't work. If that's the situation for you, you may want to enable this option to forward unknown multicast traffic. In this lab environment, we can easily simulate that situation. So now this option is not enabled yet, right? That's the default setting. I have this computer which will act as the source of the unknown multicast. Then I have a host. It will try to receive the unknown multicast traffic. And here I also run Wireshark, which will monitor this port 26. Remember this port 26 is a router port, right? So we will see when the source send out some unknown traffic, whether the host or this port will receive them. From the 3 Wiresharks, let me start capturing. Okay, started. As you can see, I put the same display filter. The destination IP address is this one. I'm going to use this multicast address for the testing. So then in the terminal for this source computer, let me run this command. So basically I'm using the netcat command to send UDP packet to this multicast address and using this part. And what's the content of the message? It's just a testing message. I want to send out 888. Okay, run it. See, the packet was sent out from this source, but it's not received in this host, and it's even not received from this uplink port, the port 26. You can see nothing here in this Wireshark, right? Which means this switch, the Pro 24, didn't forward this multicast traffic to this switch. Why? Because this traffic is unknown multicast traffic. This multicast group was not registered. Let me SSH into the UniFi switch to show you more details. I'm running this command, show MAC address table multicast. I want to display the current multicast forwarding database. Okay, this multicast address has nothing to do with our testing. We can ignore it. And other than this one, we don't see any MAC address which is related to the testing group I just used, which means this switch by default will not forward anything else to any interfaces. That's why in the testing, the other switches or hosts, they didn't receive the unknown multicast because of this database, because of this forwarding table. So that's what happened. That's the default behavior. If we go back to the network controller, if we enable this option, apply changes, then go back to the test environment. Now let me run the same command again from this source computer. Okay, see the difference? Both Wiresharks in the lower part of the screen, they received the packet. We can validate it. Let me double click the received packet. See the source IP address? That's for the source computer. Then the destination is the one we specified in the command line. And if you check the data section, see what's the data? It's 888, right? That proves after we enable the forward unknown multicast packet option, this host computer is able to receive it, even though the multicast destination group is never registered. Okay, this is a short demo, and you only need to enable it if your device requires that. This ends the video. Thanks for watching.